now going to represent a syllogistic argument with a Euler diagram. Now, the fun part of this is it sounds super fancy, right? Like, whoa, look at what we're doing. And then it's really just showing relationships between statements is all we're really doing. So let's go ahead and do this. We're going to draw a Euler diagram for the following argument. Statement 1, all of Kathy's kids have blue eyes. That's a true statement. Kathy is my mom and all of us have blue eyes. Statement 2, Sandy is Kathy's kid. That is also true. I have a sister named Sandy. So the conclusion is Sandy has blue eyes. So this is the argument, right? All of Kathy's kids have blue eyes. Sandy's Kathy's kid, and therefore Sandy has blue eyes. Okay, so let's think about what this looks like, right? So basically we have a world where we have blue-eyed people, all right? So this is blue-eyed people. Within all of the blue-eyed people in the world, we have a subset that is Kathy's kids, right? Because Kathy's kids fit in that piece. All of Kathy's kids have blue eyes. So the black square that is Kathy's kids fits inside the whole world that is blue-eyed people. Now, Sandy is Kathy's kid. That means Sandy falls inside this black square because she is identified as Kathy's kid. So the conclusion is that if Sandy falls inside the black square and the black square falls inside the bluish, purplish circle, then yes, Sandy also has blue eyes because she is also inside that big circle. So this over here to the right, the circle, the square, the X, this is the Euler diagram that shows the relationship between the two statements and the conclusion, right? Which is a syllogistic argument. All right, let's do another one. Let's draw a Euler diagram for the following argument. Statement 1, all rectangles are quadrilaterals. That's true, quadrilaterals are four-sided figures. Statement 2, all squares are rectangles. That is true, that is true. And so then the conclusion is all squares are quadrilaterals. Okay, so again, let's draw the figures. So the first thing is we're talking about if we have the all quadrilaterals. So quadrilaterals are four-sided figures. So this funky colored diagram here is all the quadrilaterals we can think of. Well, rectangles are a subset of quadrilaterals, right? So rectangles would fit inside of quadrilaterals. That's statement 1. Now statement 2 says all squares are rectangles. So that means the squares will fit inside the rectangular piece. Now, just to reiterate, we know that squares are four-sided figures that have 4 right angles and 4 equal sides. Rectangles are four-sided figures with 4 right angles and opposite sides congruent. Well, if you think about a square, all 4 sides are the same, which also holds true that opposite sides are congruent. And that is why it is true that all squares are rectangles. Okay? So the squares fits inside of the rectangular piece, and the rectangular piece is inside of the quadrilaterals. Therefore, all squares are quadrilaterals. So the diagram on the right shows the big quadrilaterals, rectangles as a subset of quadrilaterals, and then squares inside of the rectangles, which means squares are also quadrilaterals. And those are some Euler diagrams.